Hello everyone. Today we are going to see the block diagram of op-amp. Means what are the blocks involved in operational amplifier in order to transfer the signal with high amplification. So now 4 blocks are involved in order to provide proper functionality, and the first block is input stage and the second one is intermediate stage followed by level shifting stage, thereafter output stage. Now what are the circuits used for the individual blocks is, for the first stage, that is input stage, we are using dual input balanced output differential amplifier, and for the second stage it is again dual input unbalanced output differential amplifier, and for the third stage the circuit used is emitter follower using constant current source, and for the final stage, that is the output stage, the circuit used is complementary symmetry push pull amplifier. Now why we have to use these circuits? Now we are going to see. Now first consider the first stage, that is input stage. Now what are the requirements of the input stage is, the input stage has required the high input impedance in order to avoid the loading on the sources, and also it requires the low output impedance for maximum transfer of signal from the input to the next stage. So these two requirements are provided by a differential amplifier. Okay, so the differential amplifier, here we are considering the type, that is dual input balanced output. Means for this input stage, two input signals are present. One is a non-inverting input signal, another one is an inverting input. Here why we are calling as non-inverting input and inverting input is, for the inverting terminal of op-amp we are giving one signal, and for the non-inverting terminal of op-amp we are considering signal 2. Okay, so signal 1 and signal 2, and here the balanced output means at the output of the first stage we are taking two outputs. We are call it as a differential output also. And the differential amplifier, what is the purpose of differential amplifier is, it simply amplifies the difference between two input signals, and this input stage will provide the voltage gain of an amplifier. Now thereafter consider the next stage, that is intermediate stage. Here the intermediate stage why we are considering is, we know that the gain of an operational amplifier is very high. The input stage cannot provide such gain. So the main function of this intermediate stage is to provide additional voltage gain required. For this purpose we are using an intermediate stage consist of cascaded chain of differential amplifier. So here intermediate stage also we are using the same circuit, that is differential amplifier, but here we are using a type, that is dual input unbalanced output. Means this intermediate stage will have two input signals and one output signal. Now see the third stage, that is level shifting stage. We can call it as a level translator also. Now why we are using this stage before the output stage is, here we can see that the input stage and intermediate stage are directly connected without using a coupling capacitors. These two stages are directly cascaded without using coupling capacitors. We know that without using a coupling capacitors, one drawback is the DC level or the DC biasing voltage level propagates from one stage to another stage through the chain of your differential amplifiers. This may causes the transistor to enter into saturation. Due to this, a distortion signal is present at the output stage due to clipping. Okay, so before means the output signal without using a level shifting stage, the output signal is a distorted signal, means some portion of a signal will be lost. So without directly connecting the input stage and intermediate stage to output stage, we have to use the level shifting stage in order to bring such a high DC voltage level to ground. So the main purpose of this level shifter is to bring the output quiescent DC level to the ground potential with minimum change in AC signal. Now the last stage, nothing but the fourth stage, is output stage. The basic requirement of this output stage is low impedance, large AC output voltage sink, and high sourcing and sinking capability. In order to meet all these requirements, we are using a complementary symmetry push-pull amplifier. Thank you.